Now coming to the pressure volume loop, here the same thing they have done, the same cardiac cycle they have represented, but the volume along the x-axis. Here again we have to concentrate what is given in the x-axis. The volume is given in the x-axis and the pressure is given in the y-axis. Now you guys have to just remember and tell what are all the events. So starting here, when will be the volume of ventricle be the lowest? Once the ventricular systole has happened and it has ejected its blood, so what will happen? There will be very little volume here. So that volume is the 50 ml. So we are starting with 50 ml. So this 50 ml will keep on adding during the filling, and finally where they will reach? They will reach around 140 ml. And from 140 they will pump out 90 and come back to 50. So these are the two important volumes I should remember. The volume is least 50 at what point? At the point A. So what is the event at A? Now we are going to represent the points also and the events also, or the lines. So coming to the points, what is the action that is happening in A? A is nothing but our end systolic volume. Don't think that the volume is less because the volume is less because systole has happened and it has thrown out the blood. End systolic volume. Immediately after the systole, what is going to happen? Isovolumetric relaxation, and one valve will open here. So near the point A, which valve will open? AV valve opens. So they can ask the points also or the events between two areas also. Then finally the ventricle is being filled and filled and filled and filled and filled. At point B, what is going to happen? The ventricle is completely filled. Now it is going to start to contract. Whenever it is starting to going to contract, what is the volume there? End diastolic volume. And whenever it is going in for a contraction, what is going to happen? The AV valve closes. At point B, we are ending it with end diastolic volume, and after that what is going to happen? Contraction is going to happen. Whenever the contraction starts, it will close the AV valve also. Now AV valve is closed. An aortic valve, I need minimum of 80 pressure, but our pressure levels are around 5 here. So till I reach the aorta, what is going to happen? There will be a contraction only, that is isovolumic contraction, and we will reach the point C. So what is the event that will happen at C? Now aortic valve is going to open and it is going to throw the blood out. So point C, there is aortic valve opening. And whenever it is thrown the blood, again the pressure will drop. What will happen at point E? Point E, aortic valve is going to close. The same events will happen in the other side of the heart also, that is the right side, where the pulmonary valve will be involved. Only difference is their pressure is going to be little less, is lesser in comparison to the aortic valves. So this is the points, various different points. Point A is end systolic volume, point B is end diastolic volume, C is aortic opening, E is aortic closure. So all these are important. Now let's talk about the events which is happening in this pressure volume loop. So coming to the events, what is the event which is happening between A and B? Our ventricle is getting filled. So this we can say it as ventricular filling. What is the event that is happening between B and C? Here both the valves are closed. What is happening? It is contracting. That is called as isovolumic contraction. And what is the event happening between C and D? Till D I am saying, I am not putting C and E. C and D, it is a rapid ejection phase. Rapid ejection phase. And what is the event which is happening between D and E? D and E is nothing but the slow ejection phase. And what is the event that is going to happen between E and A? It is going to happen as isovolumic relaxation. Now it is the pressure is dropping, the ventricle is relaxing, so it is isovolumic relaxation. So it is, these two diagrams are nothing but our same cardiac cycle only, represented in the diagrammatic format, and they are very important also. You definitely can expect an MCQ from these two diagrams. Now coming to the changes in pressure volume loop curves. So this pressure volume loop curve, what will happen whenever there is a valvular lesions? So this can be an addition. Some of the entrance examination like AIMS or another like PGI can ask these type of questions. So what will happen whenever there is a valvular lesion to the same pressure volume loop curve? Let's try to understand. So what will happen is, all of us know that stenosis means it is a block, and regurgitation means it is the flow back, like blood is being pumped and it is regurgitated back into the same vessel. So we are going to understand about mitral mitral valve and aortic valve. The same thing applies for the tricuspid and the pulmonary valve also. So let's see what will happen whenever there is a mitral valve stenosis also, and let's see what will happen whenever there is a mitral regurgitation. We are starting our discussion with mitral valve. So whenever there is a mitral valve stenosis, the stenosis is going to be somewhere here. So what will happen? There will be less filling here because it is stenosed. So what will happen to the entire height of the original diagram? The original diagram, let's take it as without any disease, let's take it as it is in black. This black diagrams are our original. So along the x-axis we have the volume and along the y-axis we have the pressure. So if the ventricle is not being completely filled, what will happen to the volume? Will the volume be increased or decreased? The volume will be less. So whenever the volume is less, what is going to happen? It is going to give me one clue. The height of the original diagram will be less now. So first clue is the height of the diagram is less. So first clue is it is going to be less than the original diagram. Second thing is the ventricle is getting less filled. So what do you think? Can it reach this levels 140? Obviously no, because aorta is trying to push and it cannot push the rest of the 30%. So this diagram is going to shift over here. And now we know that already the volume, like the total height will be reduced because the volume is reduced. So what is going to happen? It will be operating at this level. So it will be below the original diagram, but right now it will be operating in a lesser volume. Why lesser volume? Because less filling of the ventricle. So this will be the diagram which will be the for the stenosis. So what has happened here? So what has happened here? The diagram has gone below. First thing is it has gone below and to the left side. So this is what has happened in case of a mitral stenosis. We will summarize it, but mitral stenosis it has gone below and to the left side. Now coming to mitral regurgitation. Mitral regurgitation means this mitral valve is lax, and whenever the ventricle is trying to push the blood, it is pushing here also. So it is pushing to the not only to the aorta, because the valve is leak during systole, it is pushing it to the mitral side or the atrium also. So there is blood which is going here, but this blood will be less because the aorta is getting less blood now. Whenever there is less blood in the aorta, like blood is going to the aorta, what will happen to the entire curve? The entire curve again it will be below only. Again it will be below only. The entire curve will be below only. But one more thing happens here. Now this blood has gone there, and for the next cycle what will happen? There will be more filling of the ventricle, and for the next cycle there will be more filling of the ventricle. But again if the ventricle tries to go, some of it is going to the aorta, some of it is going to the, but some of it will go to the atrium. But the entire volume in the ventricle, it is going to increase now. So the entire volume in the ventricle, because of the second time filling from the blood which has gone to the atria, it is going to increase now. So my curve will be here. Now we just have to join these points. I told you the reason for going below, and it will be shifting it like this. So it is like a mirror image of the previous diagram. So previous diagram it was below and to the left. Now it is below and to the right. Now what has happened here? It's not the exact mirror image. It has gone below and to right. So that is what has happened in this condition, below and to the right. So whenever the curve is below, if they give you a pressure volume loop curve and the curve is below, we always have to think of mitral. So whenever the curve goes below than the normal, we have only two options. One, it could be a mitral stenosis. One, it could be a mitral regurgitation. What has happened in stenosis? The curve was shifted below and to the left. What has happened in regurgitation? It has gone to the right. So whenever they give the question with the curve below, then I'll go for mitral. And if it is shifted to the right, R for R, that is regurgitation. Just the mnemonic is easy. You just see the diagrams. Curve below and to the left, mitral stenosis. Curve below and to the right, R is the regurgitation. That's it. Now coming to the aortic. What happens to aortic stenosis and aortic regurgitation? So whenever there is a stenosis, what I need? I need a high pressure. So I need a high pressure to push it inside this aorta. So whenever I need a high pressure, what will happen to the height of the pressure? The pressure should increase. Obviously the pressure should increase. So what is going to happen? The curve will be above. The one thing that we are pretty sure is the curve will be somewhere above. Now I am pushing the blood as much as possible. But do you think all the blood will be pushed out? No, because there is a stenosis. So more blood will start accumulating in the ventricles. So more blood will start accumulating in the ventricles. So whenever the ventricles start accumulating blood, the end diastolic volume is going to increase. So the curve is going to be something like this. Just connect the dots. The curve is going to be something like this. The curve is going to be tall as well as narrow. Because of the stenosis, it cannot throw out the entire pressure. So it will be a little narrower, more narrower than what I have drawn. So tall and narrow. Now let's come to the condition of regurgitation. What is happening in regurgitation? Regurgitation, we are trying to push the blood, but again it is coming back. So what will happen to the volume here? Obviously, the volume will be more in case of a regurgitation, because now whatever blood I am throwing in the aorta, it is coming back again and again. So the volume increase will be a little higher in comparison to that of the stenosis. So there will be huge volume increase. And because of this increased volume, the heart is going to be stretched. And Frank Starling's law states that whenever there is a stretch of the muscle, it is going to contract forcefully. So if the heart does not fail, what is going to happen? The heart is going to operate in this increased volumes like this. Here also the curve is shifted towards higher and wider. Here the curve will be higher and wider, and it looks more uglier compared with the, here I have drawn a neat pattern, but it usually looks like a pattern like this. It's not proper curve shape like that. So this higher and wider is in case of regurgitation. So now again, if the curve is given higher, whenever they give you a normal diagram and the curve is given higher, then which valve I should choose? Below we have to choose mitral. Whenever the curve is higher, I should shoot aortic valve I should choose. And if it is narrow, it is just a pressure problem. So it is a stenosis. If it is wider, it is a volume problem. Volume is more problematic here. So volume more problematic will be there in case of aortic regurgitation. So this is pretty simple. Just remember which valve we should go for. So because always the options will be aortic pulmonary aortic stenosis, aortic regurgitation, mitral stenosis, and mitral regurgitation. Curve below, go for mitral. Curve above, go for aortic. Then you can see the diagrams, and dependingly you can choose the options. So this is the summary of it. Curve below, mitral, left stenosis. If it is going to the right, regurgitation, R for R. Then aortic, the curve will be narrow and tall in case of a stenosis, then huge and wider in cases of a regurgitation.